Right, dear students, welcome to the next session on the cables and suspension bridges, Unit 3 of your syllabus. So, last session we have talked about the cables, the syllabus that you have to study in this particular unit. And also, we have seen some of the examples of the cables, cable stayed bridges, and we have talked about their importance. Right, and after that we have talked about some introductory content, uh, the properties of cable, the limitations of it, all that we have talked about. Now let us just summarize the characteristics of cable from the earlier study, right? So whatever is covered in the last sessions. I'm going to summarize the from that content the characteristics of cable. What are the important parameters that ascertain the characteristics, the character of a cable? Okay, so let's proceed for that. Right. So here, if you see, uh, these all these points along with some more information we have already covered. That's what I said. We are going to summarize out of the last two lectures. We will just pick up whatever is required to now say this is the character of a cable. That is what we are trying to do now. Okay, I think you got my point. So cable structures are deformable structures. Okay, which means if you apply the load, the geometry of the structure is going to change. You have to understand one very peculiar difference here. So you have studied already deformable structures like beams. Okay, so the beam is deformable structure that what you have studied earlier. So right, when you apply the load on this beam, right, so this is going to deform, you know, it's going to deform. So okay, so but the geometry is not going to be changed here. The geometry, like say if you take a cross section of, let's say, rectangle, the rectangle will be remains rectangle. Okay, there is no change of geometry. But in case of cable, see, this is a cable. Okay, so this particular cable is hung between two supports. If you don't load it, this is like this. If you apply the load, then the cable is going to be like this. Okay, and I would say if you just put two loads on cable, for example, like this, that is going to be like this. It is going to deform like this. So you can see that a straight member has become a triangular shape, a straight member has become a trapezoid. Like this, the geometry is going to be changed. That is what is the difference between deformability. So a beam or column, they are deformable, but not in the sense of geometry. Okay, geometry is going to be same in those cases, but here in cables, the geometry is going to change. Okay, so cable is funicular structure. Why did you say that? Because if you load it, it is going to take a shape where it stays stable. So the same thing you see that if I take a cable freely hung between two supports, it is going to be curved, right? So no load at all. So this is a cable. Okay, I have just kept between two supports. Okay, so now if you try load this one, so just try to load it. Okay, so what is going to happen? It is going to behave like this. I just would like to uh, so what happens when you try apply the load? So this is going to become like this. Okay, so what is this shape? It is stable shape for this particular load. Okay, got it. So that is why we are calling this as funicular structure. So a cable itself is a funicular structure. It takes the shape depending on the load. Okay, right. Cables are usually made of multiple strands of cold drawn high strength steel wires twisted together. Okay, so this is what uh, we have already discussed what is meant by a strand, how strand is made of, what is meant by a cable, how cable is manufactured. So what cable consists of? It consists of multiple strands. What a strand consists of? It consists of high tensile steel wire. What is meant by high tensile steel wire? 4 to 5 times strength than normal structural steel, that is HYSD bars. Okay, so cables are mainly used to support suspension roofs, bridges, cable car system, and many other. Just to name few, these are the examples. Okay, right. They are also used in electrical transmission lines and for structures supporting radio antennas. Right. So these are all the characteristics of cable. About cable, character of a cable. Okay, right. Next, cables carry only axial tension. Okay, so if you take a cable and apply compression, it will just bend. Okay, so it won't take compression, but if you try pull it, it will resist. Okay, so you can have appreciable resistance when you try to pull it, but if you try to compress it, you can easily do it because there is no resistance. If you want to bend it, it will easily bend, so there is no resistance for bending. So likewise, you have only axial tension is possible to develop in cable. Okay, so that's why when you say only axial resistance is possible, full potential of cross section can be utilized. Okay, so this you might have heard in strength of materials. What happens to the stress development in case of beams when compared to axial tension or axial stresses? Okay, so therefore, cables are able to carry the same amount of force with much smaller cross section because more material is involved in stress resistance. That's why for the same amount of force, you can reduce the cross section. So the same is put in the other way: high strength to weight ratio. Okay, high strength to weight ratio makes cables very useful where lightweight systems are required. Okay, so if you use beam, as I said in case of bridges, if you use beam, what happens? It is going to be very long span, so the bending moment will be twice the span, square of the span. Uh, that's why the you have to provide very large cross section, and that makes the self weight is going to be enormously increased. So instead of carrying external loads, it needs to carry its own weight. So that's a waste of the cross section, waste of money, right? So that's a disadvantage with the beam if it is having very large cross section. Okay, large spans. So just to recall once again the characteristics of cables. So cable structures are deformable structures, and you must uh, you must clearly differentiate. Deformability means what when compared to the other regular cross section, the structures like beams, columns, and all. Okay, so here deformability means uh, not the change of shape; it is change of geometry. Okay, change of geometry, right? So where cable is funicular structure because it takes the shape of the load, and for that particular load applied to the cable, that geometry is stable geometry. That's what is called funicular structure. Okay, so cables are usually made of what they are made of is they are made of strands. What a strand is made of, it is made of high strength steel, right? What is high strength steel? It has 4 to 5 times that of structural steel, the strength. Okay, I mean yield strength, Fy value, right? What is the use of cable? It is to support suspension roofs, bridges, cable car system, and also electrical transmission lines, radio antennas, many uses. Okay, then how or why you prefer cable when compared to the beam? Okay, because it is going to have axial tension only. That's why full cross section material, 100% material will participate in the load carrying. So that's why you need less material, so less cross section. Okay, right? So the strength to weight ratio is high for cable than beam. That's why we prefer cables. Okay, so whereas beam has got uh, when the span is very high, is this you should remember. When the span is very high, the cross section required is very high. uh, the weight will be the weight of the beam or the girder structure itself will be very high. So the most of the money you have to put it to the construction of the structure itself rather than for the purpose of taking the external loads. Okay, so this is regarding characteristics of cable. Okay, so let's discuss general cable theorem, what the cable has to satisfy in the next lecture. Okay, thank you.